Okay, let's take a look at the Chapter 6 test review. I'll learn to speak someday. And there it goes. And I'm not going to do this by hand, so I'm going to show it all in the calculator. This one we got 5x plus 18y minus 20z is equal to 17, and 2x plus 9y minus 11z is equal to, and x plus 3y minus 3z is equal to 5. It says use Gaussian elimination to find a complete solution or show that none exists. Well, we're going to drop the x's, y's, z's, and equals, keep the numbers in their signs. So we've got 5, 18, negative 20, 17, 2, 9, negative 11, 2, 1, 3, negative 3, 5. Let's go put this in our calculator. Hardest part on these problems is actually entering it in the numbers without messing up a sign. So do second x negative 1, go over to my edit, enter on A. So 3 by 4, rows by columns. And we got 5, 18, negative 20, 17, 2, 9, negative 11, 2, 1, 3, negative 3, and 5. Now I'm going to go double check myself. 7, okay. This is assuming I typed in, wrote numbers down correctly on my tablet. I'm going to do a second mode, and now I'm going to go do RRF. So do second x negative 1, right arrow to math, and I want to choose RREF. Make sure you choose one with 2 R's. Enter on it. Go back in the matrix menu, second x negative 1, that's actually your inverse button. Enter on A, enter again. Now we get a decimal, which kind of worries me a little bit, but I'll do math, enter. Oddball case on the first one, what are the odds? Okay, so I got 1, 0, 2, 13, 0, 1, negative 5 thirds, negative 8 thirds, and then all zeros. Now let me scroll to the right to make sure I got that. Now one way you can get this is by choosing REF instead of RREF. So let me go back and do it again. So do second x negative 1, go choose REF. Okay, I got the one, oops, got the one with 2 R's this time. Make sure to do it right. And go in, choose A. And indeed it is the oddball case. Okay. Now this particular oddball case, the reason I know it's an oddball case, 3 equations, 3 variables. Our first 3 by 3 square here should be a diagonal of 1s everywhere else, which it isn't. Specifically, the last row is all zeros. What this means is you got an infinite number of solutions. That's going to be this B right here. Now there's a certain way we want to write this. What we do is we put the x, y's, and z's back in. So put the x here, y here, z here, and equals. Put the x, y, z, and equals. Now you don't need to put it in your last row because it's all zeros, so it wouldn't go anywhere anyway. Now anything with a 0 is going to drop away. So from our first line here, we're going to have x plus 2z is equal to 13. And from our second equation, we'll have y minus 5 thirds z is equal to negative 8 thirds. So again, we just put our x, y, z's, and equals back in and drop the zeros. Now this first equation wants to solve for x. We always solve it for x. So I got x is equal to negative 2z plus 13. This one, I want to solve for y, so I take a negative 5/3 z over, and we get y is equal to 5/3 z minus 8/3. Now our answer has been this form. We put our x down, put our y down, and put it on our z. Well, x, we just said, is negative 2z plus 13, and y, we just said, was 5/3 z minus 8/3. And z, as weird as it seems, it just remains z. This is called a dependent system of equations. You can put anything in for z, and the x and y are dependent upon whatever you put in for z. Extra trivia. Okay, so we come here. Negative 2z. I'm glad to see Math Lab does this. Sometimes books introduce other variables. I always leave mine as z in my classroom, in regular classroom. So 5/3 z, oops, minus, was it 8/3? There we go. Assuming I typed it in correctly. I'm going to say next question. Okay, solve the system using matrices. Doesn't look like it's asking us for any the oddball cases here, so I'm assuming this one gives us an answer. So we got x plus 3y is equal to 0, and x plus 4y plus z is equal to 1, and negative 3x minus y minus z is equal to 17. Now, we'll write down the matrix that goes along with this, assuming I typed all the numbers in correctly, or wrote them down correctly, I should say. When we put this in, we want to put the x's in one column, the y's in one column, the z's in one column, and numbers on the other side equals in one column. So we're going to have 1, 3. We're missing the z here, so we're going to put a 0 there. Then 0 for this number. Then we've got 1, 4, 1, 1. Negative 3, negative 1, negative 1, 17. Now, rows by columns, this is a 3 by 4. So, I'm going to go to my calculator. Go to matrix, second x negative 1. Go over to edit. Enter on A. Rows by columns, so it's a 3 by 4. And we got 1, 3, 0, 0. And we got 1, 4, 1, 1. Negative 3, negative 1, negative 1, 17. And let me double check all that. 0, 1, negative 1, 3, 4, negative 1, 1, 1, negative 3. Exit out, do second mode. Go back in matrix menu, second x negative 1. Go over to math, go up to RREF. Press enter on it. Make sure you choose one of 2 R's. Go back in matrix menu, do enter on A, enter again. Okay. 3 equations, 3 variables. Our first 3 by 3 square here should be a diagonal of 1, 0s, or else. That means it worked. So this one isn't an oddball case. Our last one, the last row is all zeros. That's what told us it was the infinite solutions, a dependent system. So this will be x, this will be y, and this will be z. So our answer is negative 6 to negative 1. Negative 6 to negative 1. Okay, next question. We want to multiply these together. So we got A is equal to negative 1, 9, negative 3, negative 7. And B is equal to 6, 3, 7, and negative 8. Well, first thing, we got to input those into the calculator. So do second x to negative 1, go over to edit, enter on A. Rows by columns, this is a 2 by 2. So do 2 enter, 2 enter. And I got negative 1, 9, negative 3, and negative 7. I'll exit out. And let's go and put our other one in. So I do second x to negative 1, go back to matrix menu, go over to edit, down arrow to B, enter on it. And it's a 2 by 2. Make sure when you're inputting B, it actually says B at the top. Then we got 6, 3, 7, negative 8. Then I'll exit out. Okay, to do A times B, we'll do second x to negative 1, enter on A, second x to negative 1, down arrow to B, press enter on it, and enter again. So, we got, let's see, how do I do a bracket? Okay, there. Choose size of your matrix, 2 by 2, that looks good. I guess I gotta do okay. Okay. And this will be 57, negative 75, negative 67, and 47. And that's A times B. Okay, so let's do B times A. So I'll do second x to negative 1, choose B. You can press the 2 that's in front of it to very quickly choose it. Second x to negative 1, and then I want to choose A, and press enter. Okay, so I want to do this, choose 2 by 2, that's okay. This is negative 15, 33, 17, 119. And next question. Use Gaussian elimination again. It's got 2 other choices here, so this might be one of those oddball ones again. But let's go write the problem down. So we got 7x plus 23y plus 7z is equal to 19. And 3x plus 10y plus 5z is equal to negative 6. If I miss any of these, it'll be due to the fact that I'm writing down a sign wrong. X plus 3y minus 3z. That's not me being egotistical or anything. We're just letting the calculator do all the work. So the only thing I'm supposed to do correctly is write down the signs right, which is kind of iffy sometimes. We'll drop the x's, y's, z's, and equals, keep the numbers in their signs. So I got 7, 23, 7, 19, 3, 10, 5, negative 6, 1, 3, negative 3, 8. So let's go put this in. Go matrix menu, second, x to negative 1, go over to edit, enter on A. Rows by columns. This is a 3 by 4. So do 3 enter, 4 enter. And I got 7, 23, 7, 19, 3, 10, 5, negative 6, 1, 3, negative 3, and 8. Okay, let me go through and double check myself. 7, 5, negative 3, 22, oops, 23, 10, 3, 7, 3, 1. Okay, exit out. I'm going to go do RAF. So do second, x to negative 1. Right arrow to math, up arrow to RAF. Press enter on it. Go back in matrix menu, enter on A, enter again. And I see it didn't work. 1, 0, negative 45, 0. 0, 1, 14, 0. 0, 0, 0, 1. This is the easy oddball case. 3 equations, 3 variables. Your first 3 by 3 square should be a diagonal of 1, 0, 0 else, which it isn't, so it didn't work. Specifically, the last row is all zeros and a single 1. Whenever you have your last row all zeros and a single 1, it always means no solution. So, C, there is no solution. Okay, number 5. Use Gaussian elimination. So we got x plus y minus z is equal to negative 3. 4x minus y plus z is equal to 8. Negative 8 plus 5y minus 4z is equal to 1. Let me double check my signs. I feel like my eyes are starting to cross. Okay, looks good. Again, we'll drop the x's, y's, z's, and equals, keep the numbers in their signs. So we got 1, 1, negative 1, negative 3. We got 4, negative 1, 1, 8. We got negative 1, 5, negative 4, and 1. And let's go ahead and put this in. So do second x negative 1, go over to edit, enter on A. Still is 3 by 4, so do 3 enter, 4 enter. We've got 1, 1, negative 1, negative 3, 4, negative 1, 1, 8, negative 1, 5, negative 4, and positive 1. Okay, let me double check these. Negative 3, 8, 1, negative 1, 1, negative 4, 1, negative 1, 5, 1, 4, negative 1. Okay, that looks good. Exit out. I'm going to go do REF, so do second x negative 1, right arrow to math, up arrow to REF, do enter on it. Go back in matrix menu, do enter on A, enter again. And that looks good. 118, 22. Why does it look good? Well, if we look at our 3 equations, 3 variables, our first 3 by 3 should be a diagonal of 1, 0, 0 else, which it is. And which means this is our answer. This is x, this is y, and this is z. So our answer is 118, 22. It's 118, 22. Next question. Okay, now we want to find our inverse. Let me start a new tablet here. And it's time for it to blow up, so let me bring up a new version. There we go. So we got 1, negative 1, negative 1, 0, negative 2, negative 1, negative 5, negative 6, and 0. Now see, it's asking us to find a to the negative 1 power. That's not a to the negative 1. That's our inverse notation. So let's go first input this into our calculator. So I'm going to go to matrix menu, second x negative 1. I'm going to go over to edit, so I left her over to that. Enter on A. It's a 3 by 3, rows by columns. So 3 enter, 3 enter. Then we got 1, negative 1, negative 1, 0, negative 2, negative 1, negative 5, negative 6, and 0. -1, -1, 0, -1, -2, -6, 1, 0, -5. Okay, so exit out. Now to get the inverse, we first go back in our matrix menu, second x -1. We're under names, we press enter on A. And then we push this button I've been referring to as x -1. It's actually our inverse button. And it looks like it puts a -1 power. That's not -1 power, that's notation. Then we press enter. Typically you get fractions at this point. Then you do math, enter, enter. But they designed this so it comes out nice. Not used to that. Thought it did something wrong to begin with. Okay, so I choose that, and I choose this. Do my bracket. This is a 3 by 3. Okay. Click in there, do 6, -6, 1, -5, 5, -1, 10, -11, and 2. Hardest part is actually typing in what your calculator is telling you the answer is. Next question. Evaluate the determinant. Okay, well this might be so easy I could do it by hand. Those vertical bars tell us the determinant, in case you're wondering. It's not the absolute value. When I say it might be so easy to do it by hand, when you got 2 by 2, you cross multiply here and cross multiply here. So you first got 4 times 5. You have to do it in the direction I'm showing you here. So the first this direction, and then this direction. Is that a 9? Yeah, 9 times 9. And then you always put a minus in between them. So we're going to have 45 minus 81, which gives us -36. That's our answer. Well, we can do it on the calculator though, and I'm going to do that just double check my math. So let's first go input this matrix in. Okay, so I'll go to my matrix menu, go over to edit, enter on A. It's a 2 by 2. And it's 4, 9. So 4, enter, 9, enter, and 9, 5. So 9, enter, 5, enter. Exit out, so I do second mode. Then I go back in my matrix menu, second x -1. I'm going to right arrow to math, enter on DET. Go back in my matrix menu, do enter on A, enter again. 4 times 5 is 45. Simpleton. 20 minus 81. Jeez. Some of that new math you have there. Good thing I double checked myself. I would have missed that one. -61. I'll blame it on the fact I just woke up an hour and a half ago. Has nothing to do with it at this point. I woke up, but let me do next question. Let me grab some caffeine here. Maybe that's what I need. Okay. It tells us a lot of different information here, but we're given a matrix, and specifically it says find the inverse. Now, if you're going to use a calculator, then you don't need all that extra information. If you're doing a test in the classroom, you do, because we need to show those steps, but we obviously don't here. So we got 1, -2, 1, and 3. And we want to find the inverse. So let's go put this in our calculator. So do second x -1, go over to edit, enter on A. It's a 2 by 2, rows by columns. And this is a 1, -2, 1, and 3. Exit out. Now go back in my matrix menu, second x -1, enter on A, and then I push this x -1 button, this inverse button, and then press enter. Gives us decimals. We know how to handle that. We do math, enter, enter. And this would be our answer. Okay, so come down here, choose my matrix. It's a 2 by 2, so that's okay. And then I got 3/5, 2/5, negative 1/5, and 1/5. And next question. Evaluate determinant. Well, I'm going to go put this in my calculator first. Actually, I guess there's no need for me to write it down. Let me just go straight to my calculator. I'll quit bouncing around here in a minute. Okay. So I'll do second x to negative 1. Go over to edit. Enter on A. It's a 3 by 3, rows by columns. And we got 4, 0, 0. And 1, negative 1, 2. And 1, 3, 4. And evaluate determinant. So I'm going to exit out, so I do second mode. Do a second x to negative 1, go back in my matrix menu. I'm going to right arrow to math. And I'm going to do enter on DET. Then I'll go back in my matrix menu. Choose A. And press enter. And that gives us negative 40. And next question. Okay. Find the following. So I guess I want to input those in first. So do second x negative 1. Go over to edit. Enter on A. Rows by columns. This is a 2 by 2. And we got 5, 5, 8, 2. So 5, 5, 8, 2. I'm going to exit out. Go back in my matrix menu. Go over to edit. Down arrow to B. And it's a 2 by 2. So do 2 enter, 2 enter. Mine already has 2's there, but 6, 9, 0, 7. So 6, 9, 0, and 7. Okay, first thing I want to do is A plus B. So I'll go in matrix menu, second x negative 1, enter on A, plus, second x to negative 1. Want to choose B, I can press B by just simply pressing the 2 that's in front of it, and enter. Okay, so for this one, this is going to be a 11, 14, 8, and 9. And now I want A minus B. So I go in matrix menu, do enter on A, minus, go back in the matrix menu, choose B, enter. Okay, then we're going to have negative 1, negative 4, 8, negative 5. Negative 2A. So I do negative 2, go in matrix menu, do enter on A, enter again. And we'll have negative 10, negative 10, negative 16, negative 4. 3A plus, I think that says a plus, 3A plus 4B. So 3, go in matrix menu, get A, plus 4, go back in matrix menu, choose B, and we get that. So we're going to have 39, 51, 24, and 34. And assuming I typed everything in correctly, which is kind of iffy for me, it should be 100. It should be 60. Let's do submit test. Yeah, that looks good. Should be. The calculator did all the work for us, but good results. The idea in college algebra is you start performing these functions as you would in real life. In real life, you'd use technology to find this. Math error in real life costs money, and they don't want you to make a basic math error because you decide you want to do it by hand. They want to use technology to get the valid results. But anyway, that's a Chapter 6 test review.